education providers, regardless. Today, we're going to look at Unit 7.1. However, but in our in our previous unit, which is Unit 6.2, we looked at the budgeting and the proposal development strategies for the integration of ICT in TVET. So today we're going to look at Unit 7.1, which is the potentials of the integration of ICT in TVET. So by the end of this unit, we're supposed to develop an understanding of the potentials of ICT support in TVET and familiarize learners with the international promising cases of ICT application in teaching and learning. So looking at the study flow chart, we can see how ICT pedagogy can support TVET. One, towards ubiquitous learning, towards authentic and simulated learning, towards enhancing engagement and social learning, and towards promoting reflective learning and knowledge creation. In each and every one of these ICT measures, we're going to look at the promising cases. Promising case from Challenger Institute of Technology Australia, Online Lifelong Education Institute Republic of Korea, Singapore Polytechnic Classroom, Flipped Classroom, and then ePortfolio by Boss Hill Institute Australia. So, the Education 2030 Framework for Action, which outlines how to translate the global commitment into practice, recognizes the immense potentials of ICT in achieving lifelong learning for all. Now, it highlights the need for ICT to be harnessed to strengthen education system and to assist in increasing knowledge dissemination, in expanding access to information, improving the quality and effectiveness of learning, and providing more effective services. The same Education 2030 vision was affirmed by the Kandau Declaration, which was articulated at the International Conference on ICT and Post 2015 Education, which noted that ICT can improve access to education and inclusion, support open education and resources and solutions, support quality learning, facilitate lifelong learning pathways, as well as enable online learning and improve mechanisms for quality assurance and recognition of learning. ICT is a powerful means to increasing access to quality and lifelong TVET, and enhance the relevance and authenticity of learning, and it enables workplaces to be brought into learning. Although hands-on practical training cannot be replaced by technologies, modern technologies are able to enhance the acquisition of practical skills under a fundamental assumption that learning is essentially a social phenomenon. To enhance ICT pedagogies, learning can be supported in 4 ways. ICT can promote flexible lifelong learning. ICT can enhance learning engagement and social learning. ICT can provide authentic and simulated learning practices. And ICT can promote reflective learning and knowledge creation activities. So if you look at the 2017 ICT Development Index by region, you will see that Africa has the lowest percentage of ICT Development Index of 2.64. Europe has the highest ICT Development Index of 7.50, followed by America, followed by CIS, 6.05, then America, then the Arab states, and then Asia and Pacific. If you look at the 10, you discover that the world average is 5.11, and only Europe America and CIS got to the world average. Others are below average, but Africa's case is the worst. So hence the need for TVET transformation using ICT integration. Here, therefore, we present series of international promising cases of organizations that have implemented enterprise-level e-learning as well as staff development practices. We're going to look at promising cases that is geared towards ubiquitous learning, lifelong learning. We're going to look at promising cases that is geared towards enhancing learning engagement and social learning. We're going to look at promising cases of organizations that applied authentic and simulated learning approach. And then we're going to also look at cases that promoted reflective learning and knowledge creation. Now, each of these study cases, each case study covers the institutional background, the challenge that the TVET organization used ICT to overcome, and the description of the project and the learning insights for increasing access to quality training through the use of ICT to shift the pedagogy paradigm to TVET. So first is ubiquitous lifelong learning. And the project title is Online Learning for Adults by Challenger Institute of Australia. The country is Australia. Now, Challenger Institute of Technology is a technical and further education institution based in Fremantle, Western Australia. It offers more than 140 career development programs that cater for industrial training areas. In April 2016, South Metropolitan Tafe incorporated Challenger Institute of Technology and now provide services to both urban and regional communities. Now, Challenger Institute of Technology is one of the post-school programs, offer one of the post-school programs for adults. One of the Challenger Institute post-school programs for adults is the Certificate 2 in General Education for Adults. And the major challenges are mature age students returning to work or education. They have students with special needs and limited education, and these students have limited education background. And some of them are undertaking training as part of a welfare scheme. Now, it is a traditional classroom-based program focusing primarily on mastering learning. Distance learning is possible with paper-based resource mailed to students who then communicate with instructors via telephone and email. The diversity within the students' cohort means that some students struggle with learning in a classroom setting. Now, some do well because they like the social aspect of the classroom learning, while others find it intimidating, non-productive, or unsafe. And then some distant learners struggle because they feel isolated. So after realizing that many people were not benefiting from the training due to these learning realities, the Institute administrators decided to provide a better, more needs-driven service to students. The online version of the Certificate 2 in General Education for Adults aims to provide a more individualized, student-focused learning experience with a strong relationship between teachers and students, offer a more productive, supportive learning environment for distance learning, 288 skills and the future of work, strategies for inclusion, inclusive growth in Asia and the Pacific. Provide a more flexible and accessible learning environment for students, and provide a product that is accessible to students from great geographical distances. Now, in designing the online program, the Institute applied constructive pedagogies because most of the learning activities were cognitive driven. It was also critical and reflective. They also applied critical and reflective practices because it is the core of the program. Now, learning insight for increasing access to quality training. Online instruction provides learners with greater flexibility in accessing learning resources and support, since geographical location is no longer an issue for students. TVET organization requires time and commitment from the teachers for effective program. Therefore, CIT recognizes continuous improvement of programs and adjust online programs based on students' feedback. A contributing factor to the course's success was the Australian government policy of promoting flexible learning. The Flexible Learning Advisory Group on ICT in TVET sector oversees the regulatory guidelines, platforms, resources, and network of practitioners. Now, let us look at the virtual training. Virtual training is covered under authentic and simulated learning practice. And the Online Lifelong Education Institute, Republic of Australia, presented a case study here. The Online Lifelong Education Institute within the Korea University of Technology and Education is a hub of online vocational training specializing in technology and engineering. The institute relies largely on interactive and experiential e-learning practice by incorporating new technologies into its online learning environment. Funded by the Korean Ministry of Employment and Labor, ULEI has developed and now offers more than 200 online courses free of charge to industrial workers and job seekers on mechanics, electronics, mechatronics, ICT, design, materials, architect, and chemistry. What are the challenges? Some of the challenges are cost of equipment installation. Instructors could only teach using books, images, or video clips. Interactive hands-on activities were typically not possible. Now, the project details. Recognizing the need for more hands-on learning with industrial equipment, the ULEI administrator developed virtual training content using simulators, emulators, and virtual reality, and augmented reality softwares. Through specialized ICT, students can now learn about various types of equipment, including macro-sized tools, ultra-mini tools, and highly expensive equipment that institutions cannot afford to buy. They also learned how to stay safe in dangerous work situations through the online platform. Students log in to access the learning content at any time to study and practice adequately. Since 2007, ULEI has developed 31 virtual training courses in subject areas such as mechanics, electronics, mechatronics, architecture, design, and new energy, and offers them in 141 training centers, both public and private. Deploying these courses, the center have so far trained 24,418 students. So this is a picture of these 3 types of virtual training components in scenarios and equipment. So the types of equipment like turbo generators, hybrid automobile, clean diesel automobile, wind generator systems, and then the types of equipment as absorptive hot and chilled water system, concrete construction, surface mount technology, inline system, manufacturing process for solar batteries. And then the type of equipment also include electro, hydraulic control, servo control, and the rest of them. What are the learning insights to enhance skills development? The ULEI administrators surveyed students from 2013 to 2015 to evaluate the virtual training courses. They found a high level of satisfaction. For this practice to be effective in supporting skill mastery, it is important to choose subject areas that have good virtual training content. While the virtual training content allows students to work with expensive equipment or learn a machine in a dangerous work situation, developing the software is also expensive. Hence, the institution had to choose wisely and think carefully about how long the content will be relevant before the technology becomes obsolete. Also, the institution also realized that providing virtual training content freely over time to its training centers reduced overall vocational training costs. Now, we look at innovation in vocational education and skills training in Africa, Invest Africa. we introduced this promising case just for us to have a feel of what Africa have been up to in the past years. A 2-week UNESCO Europe Key Forum on the implication of the information and communication technology revolution for TVET highlighted the need to incorporate ICT into TVET and raised concerns that teachers may not always be prepared to use ICTs in their teaching. So in response to these findings, the Innovation in Vocational Education and Skills Training in Africa program was established in 2010 by the Commonwealth of Learning in partnership with the Commonwealth Association of Polytechnics in Africa. The dominance of traditional ways of teaching and the slow adoption of ICT-based teaching and learning were seen to be among the critical challenges in transforming African TVET. Therefore, the aim of Invest Africa were to develop capacity in the use of educational media and technology in CAPA members institutions in order to, one, expand access to TVET to the informal sector, help the huge numbers of poorly educated, frustrated, and unemployed youth who are locked out of the formal skills training system, address the unequal training opportunities fostered by inequalities based on geographical location, gender, and socioeconomic factors, and then improve the quality of TVET offerings in general. So Invest Africa and institutionalizing ICT-based method. The Invest African Council ICT teaching and learning concerns opening up systems through the development and use of OER that are self-instructional and have open licenses to progress beyond classroom-based learning, offer opportunities to non-traditional learners and learners in the informal sector, develop flexible, digitally mediated learning environment that support learning at a distance, adopt a learner-centered approach to learning that embraces self-instruction and self-directed and self-paced learning, enable teachers to play the role of facilitators of learner-centered learning, and challenge traditional gender stereotyping in skills development. The ICTs used to provide these opportunities can include printed text, audio and video recordings, and teleconferencing, DVDs, radio, television, SMS, mobile phones, and computer networks. Invest Africa approach focuses on developing a whole new TVET system, wherein the use of these new tools and methods is integral to the fabric, culture, and operation of the institution. It is intended to catalyze systemic transformation by changing the policy making and strategic planning to enable the integration of the new flexible and blended methods. The organizational structure to enable the development and delivery of these new forms of learning and content, the technology infrastructure to support the management and optimal use of digital technologies, and educational media to support and enhance classroom and distance learning and teaching, the learning and teaching practice of teachers by raising awareness of and developing their competencies in the new modes of delivery, the numbers, locations, and types of learners to whom the training opportunities are provided by promoting the inclusion of learners in the informal sector. Finally, traditional, cultural, and institutionalized gender biases by mainstreaming gender equity and encouraging the recruitment of girls and women into male-dominated technical and vocational areas. Through a range of Invest Africa capacity building, partnership development, and community of practices support activities, the two Kenya and Zambian colleges were helped to institutionalize the new forms of development and delivery and install the technology and infrastructure as below. So we have the Rift Valley, We have the Rift Valley Teacher Training Institute. We have the Technical and Vocational Teachers Colleges. So these are the issues raised in policy making. The Rift Valley Teacher Training Institute policy statement, why the Technical and Vocational Teachers College amended the existing open and distance learning policy statement. In organizational structure, the Rift Valley identified a champion for the new method of teaching and learning, established an ICT office and a flexible and learning office as part of the Office of Academic Deputy Principal, while the Technical and Vocational Teachers College established an open and distance learning department, established champion team in the various teaching departments, created collaborative partnership with other institutions to create space for their distance learning students. In ICT infrastructure, gender equity, and the informal sector learners, you can see the various contributions made by these two institutions. Now, in virtual and augmented reality, we are looking at Institute of Technical Education, Singapore. The Institute of Technical Education is a post-secondary education institution established in 1992 under the Ministry of Education in Singapore. As one of the providers of career and technical education, the ITE mission is to create opportunities for students and adult learners to acquire skills, knowledge, and values for their employability and lifelong learning, with emphasis on practical training. Is hands-on, minds-on, heart-on approach is suitable for TVET delivery. So the challenges. In the past, theory was largely taught using conventional methods. Practical lessons were given in authentic learning spaces, such as a hotel, restaurant, or aeroplane hangars. Lecturers were faced with the challenge of incorporating situated learning into their lessons. And while lecturers tried to incorporate situated learning into their lessons as much as possible, they faced challenges for the following reasons. Certain tasks were not replicable due to safety concerns, such as heavy shipyard equipment or running aircraft engines, for example. Certain tasks were difficult to replicate due to high cost and limited budget, such as floristry courses, where students have to decorate venues with floral arrangement for large-scale events. Authentic work environment we are not applicable, such as adverse weather conditions at seas, for example, cannot be scheduled. Due to its recognized need for more authentic learning experiences. Therefore, we present the project details that the IT Academy leaders introduced two types of immersive technologies, the 3D virtual reality and 3D augmented reality. The school worked closely with technology solution providers to design relevant learning activities for students based on curriculum requirements. The 3D virtual reality system has the multi-work 3D virtual reality IQ, which is a revolutionary PC-based multi-sided immersive environment in which students are surrounded by virtual images and sounds. So iCube is a high-end visualization system that can be configured with 4 to 6 walls made of light-enhancing rigid materials. Students interact with an authentic 3D environment using motion tracking devices and the system built-in collaborative capabilities to discuss and explore solutions. For example, students in the marine and the offshore technology course use the IQ technology to practice their skills on a simulated oil rig platform. Example, surfeit on adverse weather conditions and on variety of environmental conditions and associated job hazard. Now, the 3D augmented reality applications enable students to interact with the real-world environment using real-time data, thus contextualizing knowledge for just-in-time learning. Example, students in the aerospace technology course can load 3D aircraft engine model into mobile devices and watch simulations of these engine parts in the augmented reality view. This 3D simulation help them to visualize details of the complex system and the operational low inside the equipment. The 3D virtual reality and 3D augmented reality will make immersive hands-on practice possible, thus expanding the scope of authentic learning space for ITE students. Then what are the benefits of the 3D virtual reality and 3D augmented reality? The benefits are appreciate the constraints of work environment, appreciate the complex interdependency of the component parts of the system, make task-based decisions and must face the consequences of their decisions, promoting authentic learning through collaborative problem-solving tasks. The learning insight to enhance skills development from the 3D virtual and the augmented reality learning. As with any technology, the design and development of 3D virtual reality and augmented reality learning resources must be driven by curriculum requirements to justify the high cost for industry-specific skills development. For the technology to be appropriate to the curriculum, it is essential to have close partnership between schools and the massive technology solution providers when developing the content. The use of the 3D virtual reality system requires a dedicated space. The cost is significant, so a dedicated budget is also required, especially if a massive environment are installed on multiple campuses. For 3D augmented reality, the cost is low because students can use their own mobile devices or school supply devices. Now, let us look at the third um, case study, enhancing learning engagement and social learning. We're going to look at the flipped classroom by Singapore Polytechnic, Singapore. The Singapore Polytechnic was set up in 1954 to produce highly skilled graduates to meet the critical human resource needs of the economy. Today, it offers 47 full-time diploma courses and 32 part-time courses through 10 academic schools. The Singapore Polytechnic prepares the students for university and the workforce and has an enrollment of about 16,000 full-time and part-time students. The challenges. Previous teaching practice is made up of traditional face-to-face lectures and tutorials. Technology integration concerns at the Singapore Poly. Technology integration is a serious concern at the Singapore Polytechnic, and students lack motivation to learn. Project details. In 2014, the School of Electrical and Electronic Engineering implemented a three-phase flipped classroom, pre-class, in-class, and post-class pilot project among first-year students studying digital electronics. The three phases of the flipped classroom are: for the pre-class phase, students watch short video clips on a particular topic at home and familiarize themselves with the basic concepts and facts. In class, lecturers use short quizzes to check students' understanding of the material covered in the video clips, evaluate students' readiness for more difficult topics, and determine the topic that needs elaboration during class. And at the end of the lesson, every lesson, students do an exit poll to evaluate the technical learning experience and to determine areas that they have not fully understood. To develop lesson packages, the lecturers use they use screencast-o-matic and soft chalk softwares, and they also use Camtasia. These are lesson. These are softwares for uh, virtual. These are softwares for flipped classroom or for video streamings. The Singapore Polytechnic uses a learning management system to deliver the electronic learning packages and e-learning activities. For quizzes, the lecturers used quiz tools like Socrative and Kahoot. All students were required to bring their own laptop computers to class to access the learning resources and online activities. Throughout the semester, the WhatsApp online communication was used to inform students of new resources and quiz deadlines. This app was also used to maintain a two-way communication and ensure timely feedback with students. With the flipped learning resource available online, students are able to learn at their own pace, and the quizzes provide useful feedback to them. With the flipped learning resource available online, students are able to learn at their own pace. We've said that. So at the end of the pilot testing, Singapore Polytechnic conducted a study survey to assess the experience and its impact on their learners. Most students found that the class learning materials and contact with their lecturers via WhatsApp were useful in preparing them for the face-to-face section. In the classroom, students enjoyed the use of Kahoot and class discussions. The final quiz was seen as useful in clarifying areas in which they needed more work, and students saw it as a means of providing feedback to their learners, to their lecturers. The learning insights. In flipped learning approach, the teacher should have the mindset of adopting learner-centric delivery. For example, the teacher should have the professional discipline not to simply reteach the content, but plan appropriate in-class activities that build on the home learning and emphasize the application of knowledge. The combination of high-effect teaching method with supportive communication and educational web tools must be reviewed frequently to ensure that the workplace practice of scaffolding for learning is constantly reinforced. And finally, promoting reflective learning and knowledge creation using e-portfolio from the Boss Hill Institute, Australia. Boss Hill Institute is a leading vocational and higher education provider known in Australia and overseas for its collaborative and creative approach to education. It offers a wide variety of courses to local and international students and various delivery modes, including full-time, part-time, and off-campus courses. As of 2016, Boss Hill had about 40,000 students enrolled in its campuses in Australia and in licensed partners overseas. There are some challenges faced by Boss Hill Institute, and some of these challenges are meeting the needs of the students at Boss Hill Institute during and after their studies, lack of organization-wide way of embedding e-learning that will encourage lifelong learning, adopting methodological and organizational response. Now, because of these challenges, they went into this project, and this is a brief description of the project details. Recognizing the need to assist students in acquiring pathways for lifelong learning and to embed e-learning while also supporting connection and communication between classroom learning and the workplace learning. Boss Hill introduced the Mahara e-portfolio system. An e-portfolio can be understood as a learner-driven collection of digital objects demonstrating experiences, achievement, and evidence of learning. Thus, e-portfolios are an evidence-gathering tool that students can use to show their learning achievements and to document the competencies they have attained from training courses and work-based experiences, including apprenticeships and traineeships, thus allowing them to plan for the completions of prior learning. The Mahara e-portfolio system enables learners to capture evidence of their learning through a variety of media such as video, audio, document blogs, and plans, and to share that evidence with selected audiences. Mahara combines a range of social collaborative or collaboration tools, including blogs, comments, groups, forums, and profile pages, and integrates the use of mobile devices. An e-portfolio can be a vehicle for supporting transition and students' mobility, planning and reflecting on learning and career development, recognizing skills and learning styles, verifying verification of qualifications, security and control of private information, recording evidence of employability skills. Now, the e-portfolio teachers who advocate the use of e-portfolio also design assessment strategies that integrated summative assessment tasks to ensure that the e-portfolio become an integral component of the course structure. Teachers can use the e-portfolio as a tool for learning, assessment, and means of communication. Now, this table 9 shows the e-portfolio learning contest. In biotechnology teachers teaching center, biotechnology, their contest is work placement. Creative industries, their contest is industry portfolios for fashion and music. Teaching center 3, which is business programs, is also the contest is work placement. In hospitality, work placement and industry-based recognition of pre-learning. Health and community services, work placement, industry-based recognition for pre-learning. Now, the e-portfolio system is based on a student-centric approach, process-oriented approach, and this encourages students to develop their ability to plan, synthesize, share, discuss, reflect, and create knowledge wisely. The learning insight. The learning insight to support lifelong learning. The adoption of an institute-wide strategy. Assessment strategies for e-portfolio. Teachers' level of commitment. Frequent training of teachers and students. It is necessary to design and develop templates suitable for local industry-specific content and courses. Solicit teachers' opinion and inputs because they will be both users and managers of the system. The use of e-portfolio and benefits should be integrated into the workplace learning context. Overall, it is vital to have clear communication with all stakeholders. Organization-wide policies are needed along with a phased approach. 1, expand program from first year orientation objectives to senior students, collection of learning evidence. And then 2, transition from teacher-led e-portfolio to student-driven e-portfolios. Conclusion and summary. Throughout this unit, we developed an understanding of the potentials of ICT support in TVET and presented some examples of international promising cases of ICT's integration. First, the unit highlighted how ICT can promote flexible learning, lifelong learning, enhance learning engagement and social learning, and can provide authentic and simulated learning practice, and then promote reflective learning and knowledge creation. The unit therefore concluded with a series of promising cases of institutions or organizations that have implemented enterprise-level e-learning as well as staff development initiatives. So let us look at the transformative reflection. Now that you have completed this segment of instruction, please engage in the following transformative reflection activities. Consider your learning experiences and make a critical reflection regarding the extent to which this instruction has helped you identify and explore alternative set of assumptions or reinforce your initial assumptions regarding funding proposals for the integration of ICT-mediated education in TVET. If this instruction has helped you consider alternative set of assumptions, test the validity of these assumptions by participating in a reflective dialogue with a critical friend or by engaging in self-reflection. So after the reflective reflection, I expect each and one of you to carry out these to do these practice questions. So identify 5 TVET challenges that will require ICT integration to solve, and give a detailed description of a project and the learning insights for solving this problem through the use of ICT integration. Then identify agencies and foundations that can partner with your institution or organization to develop the process. Thank you for your audience, and do well to complete the assessment under this unit, and then consult the forum when there is need for it, and have a blessed day. Thank you.